Okay, so here is example 5. I've already got our goal form written down. And let's just dive in. Notice that we already have a 1 where we want it, which is nice. Let's get this 3 to turn into a 0. And the way that we'll do that is -3 times row 1 plus row 2. Store that in row 2. Row 1 is not going to change with that, so I'm just recopying it. And -3 times 1 is -3, plus 3 is 0. -3 times -1 is 4, plus 1, oh, I'm sorry, -3 times -1 is 3, plus 1 is 4. I was thinking ahead of myself there. -3 times 4 is -12, plus 1 is -11. -3 times 5 is -15, plus 3 is -12. And then we've got our 5, -1, 9, and 13 there. Just recopying that last row since that doesn't change. Now let's get that 5 to be a 0. We'll use -5 times row 1 plus row 3. Store that in row 3. And 1, -1, 4, 5. Just recopying that the first 2 rows since they're not changing here. Okay. Now we're actually going to do this row operation. So -5 times 1 is -5 plus 5 is 0. -5 times -1 is 5, positive 5, plus -1 is 4. -5 times 4 is -20, plus 9 is -11. -5 times 5 is -25, plus 13 is -12. All right now. So now we have our first column perfect. We're going to move over to the second column. We want to get the 1 where this 4 is. And the way that we're going to do that is multiplying by 1/4. I want to point out that sometimes people will try to get a number in this position to be a 1 by adding. Now, it would be allowable. It's definitely allowable to add, but notice if you add anything involving row 1 to row 2, then you're going to mess up your 0. You'll be adding something into that 0, and that's not going to be desirable. You could, I suppose, add something involving row 3 into row 2 without that problem, although you'll run into different problems. So let's just go ahead and multiply by 1/4. Alright, so 1/4 times 0 is 0. 1/4 times 4 is 1. 1/4 times -11 is -11/4. And 1/4 times -12 is -3. Alrighty then. There we go. And so now let's, we've got our 1 where we want it. Now we just need to get our zeros in both these places. Let's start with the 4. So, or actually let's start with the -1. The opposite of -1 is 1. So I don't actually have to multiply this times anything. I can just do row 2 plus row 1, store that in row 1. And so 0 plus 1 is 1. 1 plus -1 is 0. Now -11/4 plus 4. Well, 4 is 16/4. So I've got -11/4 plus 16 fourths. So that will give me a positive 5 fourths. And then I've got negative 3 plus 5, that's 2. And of course, you can always use a calculator if you don't feel comfortable doing this arithmetic in your head. All right, now I'm recopying the rest. 0, 4, negative 11, negative 12. All right, so now my next step, I'm going to nudge this up a little so we have a little more room to work, is to get rid of this 4 by turning it into a 0. So I'll do negative 4 times row 2, because that's where the 1 is in this column, plus row 3, and store that in row 3. So since it's only row 3 that's changing, I'll recopy the first 2 rows. Okay, there's my first 2 rows, and now negative 4 times 0 is 0, plus 0 is still 0. 0 is such a fabulous number to do arithmetic with. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times negative 11 fourths. Well, the 4 and the fourths will cancel, and I'll have a positive 11 plus negative 11. Well, that's going to be 0. And then I've got negative 4 times negative 3 is positive 12. I want to add that to a negative 12, and I get 0. So let's pause here and take a look. This, notice, I've got a row of all zeros. This represents the equation zero equals 0. And since I've got 0 equals 0, well, that's actually true. It's not a contradiction like in number 4. It doesn't give me much in the way of useful information. 0, yes, it's always equal to 0, but that doesn't tell me anything about this particular problem because that's always true. So now notice that the other 2 equations that I've got in this system both represent a plane. So I've got one plane here and one plane here. My solution, well, I've got one plane here, and the true fact that 0 always equals 0. So that's not actually going to help me solve this. So I can focus just on the planes that are unique in the system. So I have 2 planes. So either they are parallel or they intersect in a line. Now, if they were parallel, one of these rows would be an exact multiple of the other. That's what we saw in example 4. Now, that's not what we have here. So I do have my 2 actual planes that actually do intersect. And notice I have done all that I can. I've gotten this as close to my goal form as I can. There's no way to get a 1 here. I can't multiply by 1 over 0 because that's undefined. If I add one of these other rows into the 3rd row, I'll lose the zeros that I do want over here. So that row is going to stay all zeros. Without having a 1 here, there's no way to get rid of these numbers and turn them into zeros. So they're just going to stay there. So now let's translate these rows back into equations. So that's going to give me row 1 will give me x plus 0y, so I'll just ignore that, plus 5 fourths z equals 2. And row 2 gives me the equation y, 0x plus 1y, that's just y, minus 11 fourths z equals -3. Now it's easy to rearrange these and, whoops, I'm bumping my paper around. Okay, it's easy to rearrange these and get, so because of this one, so x is equal to -5/4 z plus 2. And because of this one, I can rearrange that, so y is equal to +11/4 z minus 3. So now I know both what x and y are in terms of z. So the solution set and we'll even say whose graph is a line, just as a reminder to ourselves, is the set. So remember how our set builder notation goes. I can write what's in the set here. So it's the set of all points. The x-coordinate has to be equal to 5/4 z plus 2. The y-coordinate has to be equal to 11/4 z minus 3. And the z-coordinate, well, everything here is in terms of a z. So the z-coordinate, I can just write a z. And then we have a vertical bar. And that's going to be true for all real numbers, of z. When you are putting your answers into the, rearranging this a little bit. When you're putting your answers into the My Math Lab in this section, it will actually have you fill it in. It's written slightly differently. You're going to write the point exactly like we have here, but they want to allow for some classes may skip using the set builder notation. And so they just put it in the set and say for all real numbers z. Notice that these two things mean the exact same thing, except since our class did cover set builder notation in depth, you will be expected on tests to, well, all we've got left is the final exam, but on that test, to be able to put your answers in set builder notation when called for. And remember this with the vertical bar in it, that's set builder notation. Alright, that is it for this video, and this is our final example.